order to begin learning geometry, you first need to understand these undefined terms, which are point, line, and plane. A point is just a dot. It's a speck that we draw to represent a location. It doesn't have any dimensions. We name it with a capital letter. If you were to string a bunch of points together and put them infinitely close together, you would get a line. A line just has one dimension. It just goes in one direction, left, right. But it has no width to this line. It's like an infinitely skinny string. And then actually, if you were to stack all these lines together, it would begin to fill in a plane. Planes are usually represented with a rectangle or parallelogram of some sort. You can think of it as just a flat surface. It does have length and width. It's two dimensions. Then from there we can go on to define space. Space is the set of all points. Space is three-dimensional. Then collinear just means on the same line, and coplanar just means on the same plane. Something could also be non-collinear or non-coplanar, just meaning it's not on the same line or same plane. Now we can begin to talk about some postulates. Our first postulate that we'll go over is that every line contains at least 2 points, 2 distinct points, meaning different. So every line has at least 2 points on it, even if they're not marked. 2 points are contained in one and only one line. So there's not another line that can go through those 2 points, because lines can't be curved, they have to be straight. If 2 points are in a plane, then the line containing these points is also in the plane. If there's 2 points, it goes back to that same idea as we talked about in 2.2. Lines can't be curved, they have to be flat, they have to be straight, so it would be in the plane. 3 non-collinear points are contained in one and only one plane, and every plane contains at least 3 non-collinear points. So if you have 3 points that aren't in a line, there's one and only one plane that contains them, and every plane has at least 3 points. Well, the first part of that, 3 non-collinear points, is in one and only one plane. I like to think about that one by just using 3 fingers. Imagine your fingertips as points. There's only one plane that you can make. So if you were to take a book or a piece of wood or cardboard or something firm and balance it on your 3 fingertips, it will balance exactly. It'll touch no matter what. And there's only one plane that'll do that. It means there's no wiggle to it, really. And every plane has at least 3 points. Pretty much the same idea, just a little bit backwards. And then our last one here, in space there are at least 4 points that are not coplanar. That just means that there is 3 dimensions to space. So now getting into a little bit more math from definitions. The ruler postulate states that every line can be made onto a copy of the number line. And then once you do that, you can talk about coordinates. Coordinates are just a point or a location on the number line. We can talk about distance, and to find distance, you just see an absolute value of the difference of the two things you're trying to find the distance of. That's how far apart they are. But the distance between A and B would be the absolute value of A minus B. If you have a second point on here, then you can draw in between there and create a line segment AB. And in a line segment, these 2 points on the ends are called the endpoints. You could then talk about the length of that line segment. Line segment would be named AB with a line segment above it. Talk about the length of AB. If you're talking about the length, you don't put a line segment above it. And if we use these points up here from -2 to 1, you can either count 1, 2, 3, or you could do what we talked about for distance. It's the absolute value of their difference. -2 minus 1 would be -3, absolute value, +3. And if two segments have the same length, they are congruent. Let's say same measure. Then they are congruent. The symbol for congruent is an equal sign with a squiggle above it. If we go back to the beginning here, you can name a line by 2 points that are on it. But if you're naming that line, you write those 2 letters, those 2 points, with a line above it. If you're naming a plane, you have to use at least 3 points, do a little symbol for plane, and then write those 3 points. They don't need to be corner points of the plane, they could be inside like that. A ray has one endpoint and then goes forever in one direction. You could label it like that. An angle, we get an angle by putting 2 rays together where their endpoints match up. We call that the vertex. We call the rays that make the angle the sides. And since we have the 3 points, we need 3 points to name an angle. This would be angle DEF. The vertex has to go in the middle. Or you can also just use the point that's the vertex to name the angle also, as long as there's only one angle at that vertex. To measure angles, we can talk about the protractor postulate, which is similar to our ruler postulate from before. We can match up an angle with a protractor and then get the measure of the angle because it matches up in a 1-to-1 correspondence with the degrees on there. So if we look at this angle here, EBD, there's an angle. One side starts at 0, the other side goes to 60. If we want to talk about the measure of an angle, you write the angle, but you put a little m before for measure, and you can say what the measure is. In this case, 60 degrees. We could also do angle DBC. So that goes from 60 to 150. You can find its measure by subtracting. 150 minus 60 is 90. From there we can talk about different types of angles. Different angles between 0 and 90 degrees, we call it acute. If it's exactly 90 degrees, we call it a right angle. If it's between 90 and 180, we call it an obtuse angle. If it's exactly 180 degrees, we call it a straight angle because it makes a straight line. And if it's more than 180, between 180 and 360, you have to mark it special with the actual curve, showing that you're talking about the larger part of the angle. Otherwise, you would assume it's the inside, the short part. But that's called a reflex angle. You can mark a right angle just with a box in the corner of the angle. And if you have two lines that intersect at a right angle, then they are perpendicular. The symbol for perpendicular is an upside down T. If these lines were just labeled with lowercase letters, which is also acceptable, you could say line L is perpendicular to line M. With angles, we can talk about congruent angles as well. If they have the same measure, they are congruent. Complementary angles are two angles that add to 90 degrees. So for example, a 60-degree angle and a 30-degree angle would be complementary angles. Supplementary angles add to 180 degrees. So for example, 120 degrees and 60 degrees would be supplementary angles. And adjacent just means next to. So that means they have to share a vertex and a side. They have to share a vertex and a side. So these two angles are adjacent. They're next to each other. So now let's look at an example involving angles. We're told that CG is perpendicular to GE, and that's marked with a right angle there, so that's good. AGB is 77 degrees. That's marked. That's good. Angle CGD is 54 degrees. That's already marked. And angle FGC is 157 degrees. FGC. So this whole part is 157 degrees. That's not marked, so we'll just have to remember. Determine the measures of angle DGE, BGC, AGF, and FGE. So let's just go in order. The measure of angle DGE. DGE. We know that this whole part here, CGE, is 90. So if we subtract 54 from 90, we'll get its measure, which is 36 degrees. Angle BGC. BGC. So if we look, we do have a straight line here, which is 180 degrees. So if we subtract 77 and 54 from 180, we'll get the measure of angle BGC, which is 49 degrees. Angle AGF, so to find the measure of angle AGF, we're going to need to look at our piece of information we don't have marked yet, the FGC. This whole part from F way around to C is 157, so it will be 157 minus the two measures we do know, 77 and 49. We get 31 degrees. And last, measure of angle FGE. We can look at the fact that AD is a straight line, so that's 180 degrees minus the two angles we do know. So that's 180 minus 67, 113 degrees. So that concludes part A. Part B, name one pair of complementary angles. Complementary means they add to 90 degrees, so we know we have a 90-degree angle here. So angle CGD and angle DGE are complementary. Part C, it says name four pairs of supplementary angles. Supplementary means it's going to have to add to be 180, so we do have a straight line, so we're just going to take different pairings to get straight lines, like angle AGB and BGD. Or we could do angle AGC with angle CGD. Or on the bottom side of this, angle AGF with angle FGD. Or last, angle AGE with angle EGD. All of those pairs make a straight line 180 degrees, so they are supplementary. For part D, name four pairs of adjacent. We could actually use these same pairings because all of them had the same vertex and they shared a side. You could name other ones that, like angle AGF and FGE. Those would not be supplementary, but they are still adjacent.